So our next speaker is Marilach, and I hope I pronounce your name correctly. So please correct me if I made a mistake, because I find it very important to address people in the right manners. And I kind of want to not steal away any from your presenter time. So if you want to go ahead and introduce yourself because it's part of the first slides, then let's go. Otherwise, I definitely want to give you a little bit of time to promote this awesome organization that you started this year, Marilach, to help those people that are a bit less fortunate or are like the Philippines, who really can use some sponsors to help them get to their technical goals and to make them great contributors to our community as well. So you might want to take this opportunity to promote it and ask bluntly for some sponsoring as well. So I would like to give you all the time and the floor. Thank you, Marilla.
Thank you very much. I'm really happy that you mentioned ulap.org. I hope I will have time to talk a little bit more about that. Otherwise, we have a great website where you can find everything. But yes, I'm not going to bluntly ask for partnerships and volunteers and sponsor. I'm just going to directly ask for it. But first, let me just share my screen so I can properly introduce myself. Hope everything works. All right. So my name is actually, it's pronounced Marilag, and don't worry, it's a very unique name even for Filipinos. So a lot of people don't know how to pronounce my name. And so yeah, thank you very much for inviting me here on Azure Thursday. I realize it's dinner time, so I'm gonna try my best not to make any of you lose your appetite. Just a little bit about myself. So I am a tech and social entrepreneur from Device. I'm from the Philippines, but I currently live here in Denmark for over a decade now. And as I mentioned, I'm a co-founder of ulap.org together with one of my friends, Michelle Tabirao. And we just started March. And the whole concept of ulap.org is that we find these kids right now in the Philippines, because that's our first target. These kids who are underrepresented, underprivileged, but really have passion for IT and really want to learn, and they want to kickstart, or we want to kickstart their career in cloud, and not just one cloud, but multi-cloud. So they get all the official training paths and certification from different cloud vendors. And now we're also getting a lot of partnership with online learning so that they can do self-paced training for free. It's great. So I hope you follow the development of ulap.org in my LinkedIn post, or visit our website if you want to know more. So I'm really, really passionate about the community. But today I'm putting my technical hat. I've also been a developer since I was 70 years old, and I still love code. I don't know if it loves me. So I'm going to start my presentation with a little game, and it's called the Gossip Game. We played this a lot when we were kids, and the whole idea of the game is that the master of the game passes on a secret to the first person in a queue. So you form a queue, and then the first person pass the message on to the next and to the next until the message reaches the last person, who will then blurt out the message or the secret. And the team is able to say the correct secret, the message, wins the game. And the thing is, hardly anybody wins, because you know how it is with messages if you pass it on from one person to another. That's why it's called the Gossip Game. And I really want to try to play it today, but unfortunately we don't have, we're not here physically. We can also use the chat, because I'm guessing this is live stream, so there might be a little delay. But what I want to try to do, not sure it's going to work, is still play it. So I'm going to display a short story from my deck here. And I'm going to remove it maybe after a couple of seconds, and try to remember as much as you can from the story, and try to write that on the comment section on chat, or maybe tweet or something. Just tag me, and then later after my talk, I'm going to look at the messages and find the one who got the closest to the story. And then of course I'm going to check the timestamp. So let's try it out, and I'm going to give you a prize. So let's try it out. Here it goes. Please don't cheat. Don't make any screenshots. This is just for fun. This is the story. A little bit of tech facts that could potentially turn into tech gossip. All right, one more sec, and I am going to scroll further down. I wonder who won. We will find out later on. But if you've had challenge the remembering the bits and pieces and then you try to relate again, you're not alone. So apparently what we learned from this game is messages can be very tricky to handle. And let's examine a couple of reasons why that is. Maybe it's just about insufficient memory. I suffer the same fate. But no, they say that an average person actually can only keep about 4 items in its short-term memory within 30 seconds. I'm not sure even if I can keep as much. But it's just the way our memory goes. It's so hard to keep them in our short-term memory. Or maybe there's just way too much information. They also say that we can remember only about 7 words at a time. But if you remember the words person, woman, man, camera, TV, and repeat it over and over again, you could probably run for a president. You have the IQ for that. Other reasons: you're tired, you're sleepy, you're hungry, or you're just not paying attention. You're watching Squid Game or something else on Netflix while you're watching my dog. That's completely fine. But these are our limitations as human beings, and apparently machines are not so different from us. Even though, of course, they're just a slightly, better than us. They're still susceptible with, making the same blunders. And sometimes the computer glitch, the machine glitch, is so weird that you can't really understand what went wrong. It happened to me the other day, my own brain. So I made a sandwich, a peanut butter sandwich. I couldn't remember if I ate it or not. So the peanut butter was on the counter, the bread was gone, but there's nothing in my memory that said I ate the peanut butter sandwich. So we suffered that same glitch. So this talk is really all about how can we address these physical limitations of machines using message brokering and event-driven architecture using Azure services. So there's going to be a little bit of introduction to some of the concepts for those of you who's very still new to message brokering and event reads. So I'm going to have some demo, very simple, so that we can really break it down and understand the concept behind queues, service bus, and event grid. Nothing special. And then further on, we can talk a little bit about some architectural patterns and discuss a little bit some of the design pitfalls that we can watch out for if we're working with distributed applications. My demo is in C#, so if you're not a C# developer, it's fine. I think you should be able to follow the whole concept. It's not also a niche topic, as queues and all this is really old in Azure space, but I still feel like a lot of engineers encounter challenges picking the right tool when they're dealing with distributed applications. So they just get lost in the whole distributed dungeon. So distributed dungeon, according to Leslie Lamport, who is a winner of a Turing Award, he's done massive work around distributed dungeon. He's got a really good explanation about distributed systems for Cosmos DB. Find that on YouTube. And he said in this code, a distributed system is one in which the failure of a computer you didn't even know existed can render your own computer unusable. Why are we talking about this? Because precisely all this messaging that we're learning right now is to solve the distributed problems. So if you've been a developer, network engineers, or you've just pretty much used software, you probably already encountered a very simple setup of most systems now with N-tier applications. So typically a web application would have the browser, you have a front end, you have a couple of services, backend services doing the logic, and a data. So it really looks so harmless, but it's not quite that harmless. Because if you think about it, what do you do if all of a sudden you have a surge of users? Or what if your user executes different commands on the front end and you have to process that sequentially? Or what if your service all of a sudden couldn't process the message it received because it is malformed? Or Worst, what if your database just exploded? How do you handle this? So all of a sudden, this simple test system becomes much larger or gives much larger test surface. So all of a sudden, we all have to think about the different pillars of good architecture, reliability, performance, security, operationability, maintainability, and cost at every point-to-point communication. So not just as a whole, but every time we cross boundaries, network boundaries, we need to consider this and, expand our test coverage so we avoid issues. But now let's really look at, for now, reliability and performance and how messaging can really help. So the way it works is that to be able to communicate with each other, you pass data. And two types of data for communication is message and events. So we're going to learn a little bit the difference between message and events because it's really important when choosing the right services. So what are messages? They're not, they may sound similar, but they're really not. So message is piece of data that indicates that something must happen. Remember, must happen. So if this is a producer, I can send a message to the receiver and the receiver must do some action over to that message. Message contains essential information so the receiver can execute that action. That action can be a command. For example, I need to change a state in my system. And these are very high valued message because if I do not complete this command or I receive an incorrect message, then something goes wrong with the system. The action is also maybe in charge of changing the state of the actual message. That means if I have processed that message, I can either complete it, or if something went wrong, I can put it in a dead letter, or I can defer it for later processing so that that receiver has a way to get back to the sender what to do with that message. Whereas events, if you look at events, the purpose of event is also a piece of data used for communication, but it already indicates that something has already happened. And an event may or may not trigger a reaction. So it's not necessary that a component that subscribed to that event has to do something. There's no contract between the producer and their subscriber. And event data typically also contains just a reference to a relevant entity that was changed. It doesn't have to contain every single piece of information. It could just be a reference. So for example, your event is triggered because a state has changed. Then your event data might contain the link to that entity so that you can query and see the current state of that entity. Also, you can, in your event data, you can also contain a reference for retrieving the actual data about the event, which is two very different things. The data about the event may contain this a reference to the state of the entity affected by that event, the time that event was triggered, which can be very different from the current state. So just something to think about. So if you really understand the difference or with message and event and what is required by use case, it's much easier for you to decide which Azure services to use. So very simply put, for messaging, we have Azure Storage Queues and Service Bus. But for events, we have Event Grid, Event Hub, and you can also run other event streaming services on Azure like Kafka. We're not going to talk about Event Hub, and Kafka today because these are more for streaming large events, large amount of events, for example, for IoT or logging. I want to focus on application development. So we're going to stick with this three different services for now. So let's have a quick look on Azure Queues. So if we go to my portal, I have already created the different resources. So this is my storage account, and under this you can find the queue. And here I already created queues. When you create queues, you just give it a name. Easy as that. And how do we interact with these queues? What are the typical operation to queues? As I mentioned, you need to send a message and something must receive that message. So if you look at my little demo here, how that works, let me try to call this API. So what this does is it actually just splits this whole story into words, and each word is sent as a message to the queue. That's all. And then I have an Azure function triggered by that queue to display that message, just so I can illustrate what's happening. So if I call this, you can see my API is still processing. It's not done yet, but my receiver is already processing in its end some of the items and words. Now it's done. Now I got the data. So this is also, this illustrates one advantage of having brokers in between components. This is what you call temporal decoupling, meaning your producer can and receiver can process these messages at their own time. So producer can produce the message and the receiver can just react in its own time. They don't have to be in the same time. So that's temporal decoupling and one advantage. So Azure queues are really very good for some of these simple scenarios, load balancing, load leveling. Load leveling is when you want to throttle how many requests can process by an instance of your service. For example, if you have Azure function and you don't really want to pay for auto scaling because it's not necessary, but you still want to control the amount of messages it receives, then you can use a queue. All right, so when I mean simple, it doesn't mean that you're only using it for small stuff. So there are some use cases where even for enterprises where you need Azure queues. So just to summarize with Azure queues, it helps with load balancing, temporal decoupling, and Azure queues is also good for if you need to have a larger queue size. It supports up to 500 terabytes. It also supports at least once of sending messages, but take note, it's at least once. So it can be more than once. So your application needs to be able to handle duplicates. It also has server logs. So that's Azure Queue. But one thing you notice here, let me just put that up again, the data. So here you can see the words came, but in some of my examples in my tests, the words actually did not come in the same order as the story. So it got jumbled. Often in queues, it's possible to it's often first in first out, but not always. So if you really need to ensure first in first out, you move to service bus. So let's look at the next demo. And I will show you how to implement a very, very simple first in, first out. But first, for those of you who's also new with Service Bus, I have also created one here and one that is on a standard tier because there are some, obviously, some functionality that is only available for standard tier and premium tier. So this is a standard tier. As you can see, I can also create the topics. We'll talk about that later. But here you can also create a queue. Obviously, you can also do it automatically with, with your CI/CD and infrastructure code. You just want to show it on the portal. So if I create a queue here, now there are way more configuration that I need to understand here. And each of these configuration is important when you want to implement your use case. So for example, now I want to demonstrate how to do first in, first out. So you have to enable sessions. Sessions is basically you can tag messages under the same session, and the recipient of these messages makes sure that they receive or they send the messages and receive the messages in the correct order within that session. So if it's two different sessions, of course, there's a chance that you don't receive it in, first out mode. So how do we implement this very simply in Azure Function? So again, let me show a quick demo. So I have FIFO here. This thing does the exact same thing as this first story. I also parse it. It's probably not obvious what's happening here, but I can guarantee that this is in order.
Very sorry to interrupt, but can you zoom a bit because it's a bit unclear?
Yeah, sure. Let me. How about that?
Yeah, perfect.
Awesome. Is that better?
Yeah.
Sorry. Okay. Yeah, I was wondering actually if. Sorry for not asking right away. Okay.
No worries.
Is that better? So these are just the words, right? It's hard to see for my test, but just trust me that when I try to run this against Azure Storage, sometimes two words came in two different order, which makes the story that becomes a gossip. All right. So moving on, the first in, first out guarantee that. And if you look a little bit at my very simple code for sending messages to Service Bus, so I just use the typical .NET SDK to connect to the Service Bus with an endpoint. And with the SDK, you create a sender, and then you form your Service Bus message, and then you call send. And you can see here, I pass a session ID. In this case, what I did is in my function, I just took the execution ID of the context and made that my session ID. So every word belongs to the same session because that's one call. And and then it gets sent. But the interesting part is in your receiver. So Service Bus trigger is also out of the box from Azure Function. You just give the name of your queue, the connection string here, which in this case is in the configuration. And there's something here that's quite more important. So you pass the session enabled. Yeah. Oh, because now there we go. My my mouse don't work with resizing VS Code. So you need to explicitly put is session enabled to your trigger here to make sure that it processes the same session. So if you have multiple instances of the function, make sure that it routes to the same instance that gets a session. And you can also retrieve the session ID from the message. So I think if I just take this, which is also parameter, you can also find session ID, and you can do some logic around that. But basically, very simple, first in, first out. So what if I also want to do some sort of transactions? And transaction, so Service Bus supports what you call a transaction. And a transaction just simply means that if you want to carry out several series of operations against your services or Service Bus, against your messages, you can make sure that all these operations succeed before you commit the transaction. If it doesn't succeed or one of the operations fail, then you can roll back everything. So that is also supported. In my demo, you probably won't be able to see the big difference in a transaction, but you can see here from the code, if I go like here, send message transaction. So all you have to do is enclose the call in a transaction scope. And every time you call send message sync, it's not completely committed until you call TS complete. So you can also abort the transaction, typical with when you're doing atomic operations against your database. You may or may not pass session ID. That's not required. I just wanted to make sure that they're also in order. So a lot of these advanced features for Service Bus will really help you satisfy very specific use cases in your application. Because imagine if, let's say in a shopping cart that you don't want to deliver the goods until you make sure that, the credit card, the payment has been completed. So we don't want to jumble things around. So that's Service Bus. And so now you ask, what if, right now you have seen that I have one function for, let me just close this so I don't get confused. I have one function for triggering one queue, one service queue. But what if I want several functions to receive the same messages? Then we can implement topics and subscriptions. So it's a little bit different. So if we go back to the portal here and look at the topics, so here you can also create a topic. So the idea of a topic is that you can send a message to the topic and then the topic will forward it to all its subscribers. How does that work? So if you see, if I open this up, I can find my subscribers here. I don't know why that was not scrolling. So yeah, so I have 3 subscribers here. And if I open that, so a subscriber is essentially actually just another queue, a sub queue. So your subscriber is subscribing to a specific queue within the topic. So you can do fan out. So you can also have different configuration for this specific subscriptions. For example, in subscription 1, I want to do dead lettering, and and all these things. But I don't want to do that with subscription too. So you can be very specific with your configuration. And how does this work in code? So for the sender, it's not different. It's just sending to the topic. So you pass the queue name as the topic here, for example, juicy gossips, and the whole code is basically the same. But for your receiver, that's the same. You can also have a service bus trigger for your Azure function. You put the topic name here, and you put the subscription name. This will be the exact subscription name you have created on your service bus. So this now two functions will be triggered if I send a message. So let's see. There's my Thunder client. So let me try to post something. Same, a little shorter message here. And you should be able to see. Let me just scroll down here. So you can see that I have received for this function and also received for that function. So really very simple. So what if something went wrong? So let's say in the second another subscription wasn't able to process the message, and it needs to handle that issue. So Service Bus also support dead lettering. That means that when something goes wrong, you can dead letter a message, put that in a dead letter queue. It's also another sub queue. And the thing is, with dead lettering, what happens is that the message stays in the dead letter as long as there's no handler. So it has to wait for a handler to pick it up and then also complete it. So if there are no handlers, there are no receivers from the dead, no function listening to the dead letter queue, then it's just going to stay there. There's no expiration. So if we look at the code for the dead letters, also again very simple. So I have the receiver here. And let me just uncomment this code. Oops. So one thing to note here is that this one is the same. It's just a subscription tree. But when I receive it, I put it in the dead letter. So, your message receiver as in operation for dead letter. And then I have another function that listens for that same topic, but instead of my subscription, you put the path of your sub queue. In this case, this is $dead letter queue. So $dead letter queue is something that is system defined. It's not something I invented. So you just put that dead letter queue, and it will receive the messages from the dead letter queue, and then it can also complete it. So quick demo on that. Let me try to trigger that again. See here, you can see some of the message going to the dead letter alert. So really simple way to interact with Service Bus. Let me just go back to my slide here. And we've done dead lettering. So I just want to summarize the stuff that you can do with Service Bus. It's really built for enterprise messaging services. It can guarantee, I didn't show this, but it can guarantee at most once. So it can have duplicate detection built in, unlike Azure Storage. But the downside is it has a smaller queue size. So it only supports about 1 gigabyte to 80 gigabyte of queue size. And also there is a limit on the number of queues that you can create per Service Bus namespace. I think that's around 10,000. And if you need more, I think you can contact support and request. I don't know how that works. I haven't tried creating more than 10,000 queues yet. All right, so I've discussed that lettering and all forwarding. So now let's go back to our original discussion about messages and events. So what do we do with events now? Now something has happened. The state has changed, and I just need to broadcast that without really caring about what the consumer will do with it. So one service in Azure that I can use is Event Create, which is built for pub sub notification. It's a push notification system. Actually, Event Create is what Azure services use as event source so that it can broadcast almost virtually all the activities within the Azure infrastructure so that other Azure services can react or listen to these events or your application, or if you're doing automation. Event Grid is what you normally would subscribe to. But you can also use Event Grid if you want to just, publish your application's events. We've done that in some customer project, and that works. It's also serverless. It's low cost. There are other good features about it. It does automatic retry for 24 hours with automatic exponential backup. I don't think you can really do much about this in configuration, but you can also do dead lettering. So dead lettering in Event Grid is not on by default. You have to turn it on, and then you have to specify a storage blob. So the difference, you can see that in normal service bus queue, the dead letter is just another queue that you can subscribe to listen to. So that's much easier processing. Whereas for the Event Grid, and then you have to read the blob. And what happens if the blob is not available, the storage blob? Well, then the event goes to limbo and you will miss it. Probably won't happen, but it could potentially happen. So quick way of interacting with the Event Grid service. So again, the operations for sending and receiving events. It's a little bit different than what I did before. If I go to my demo here and look at what I want to post. So if I just look at the body, I actually have a schema that I designed so that I can comply with the schema that the Azure Event Grid expects. This is not the schema. Azure Event Grid has another schema. I just sort of abstracted that away. So here I just need, as a minimum, you need an event type, which is a string that describes what the event is about, in this case, message created. And then you can have a dynamic object for your data. And typically, as I mentioned, you can put a reference to some sort of a location, like pretty much like a location header that you can call to do query about the specific entity that the event is all about. So something around that. So to make it very simple, I just use these three properties. And what I do is if I post here, I actually don't have, so nothing happens, it's just 200. I don't have a listener right now in Azure Function, but you certainly can subscribe to Event Grid. But the thing is, Event Grid is push notification. I can't do it via local host here because I need to set it up in Event Grid. But let's have a look at the internals of Event Grid. So it's looking like a typical queue, but it really isn't. So I can also create subscription on the Event Grid, like you saw in topics. This is an Event Grid topic, so it's similar to the service bus topics. But see the difference here? There are a couple of notable differences. For example, I can add an event type. That means I can filter by the event type that I want to subscribe to. Well, that's actually also supported in service bus topics. You can also do very advanced filtering so that your subscribers can only get relevant messages. So you can do that here. So for example, the one I created, this message created, something like that. So you can put it here, type that here. And Event Grid supports several destinations within the Azure space. So you can connect to function, connect to queues as well. So you can do the whole cycle. In one of our applications, we actually use webhook. So the Event Grid calls our proxy, and then the proxy does the whole security and between event grid and our system, because it needs to do message exchange to make sure that the event grid is calling the correct endpoint before our proxy hands it over to the webhook. So there's whole funny magic we did there, but it's really quite interesting. But you can, the main point is that you can use webhook. And if what I did here is I use, just to illustrate, a storage account as a destination. So if I look at my storage account, I have a queue here. Well, I just also received the message that I posted from today. I think it's this one. And you can inspect the message here. So if your function, if it's an Azure function, for example, you are going to receive this as an array of messages. So you can just deserialize that into your object if you know the format of the event data that you expect to do, and then do some logic around. Right, so that is event grid. I can see I'm almost running out of time. I have a couple of minutes, so I'm just going to speed through this. There are a lot of questions, and I'm sure you have questions about the difference between queue, service bus, event grid. There's a good link here that really illustrates how comprehensive the differences are. And I can understand it could be very tricky to really pinpoint the correct service, but just do the homework, talk with the architecture team, talk with the developers, because you really need to do cross-checking of everything that you need. Understand your use case, understand your limitations as well with your infrastructure. We also actually experienced where we implemented event grid, where afterwards we learned that we should have actually implemented service bus. So those are some of the things that you can encounter. So I have a little, maybe just to illustrate how we can put it all together in a real world scenario. So I have a diagram here of not a whole system, but just a subset of a system that we were working on. I can't show the code or the application, but I can, because it's a customer application, but I can share with you some of the architectural decisions that we made. So the whole system it's a large system for self-service portal for cloud engineers in an enterprise. And this design implements just one of the workflow for onboarding new digital products. And when you do that, there's a bunch of things that needs to happen. And for example, you can create the product and then do a lot of configuration along the way. So from a technical perspective, it's not so different from just implementing, any workflow over handling lifecycle of any entity. So let's start with, we have a static web apps as our front end. I'm sure you're all looking forward to John Papa's talk about static web apps. So we also use that in this application. So we start with a user, and then it triggers an orchestration. And since it's a long-running process that can possibly span a couple of days due to an approval, we implemented it as a durable function. So then, so the orchestration triggers the first activity, which is essentially creating the entity database. Again, another point-to-point thing that can cause us some issue. We need to be aware. So, and then it triggers the approval, which also has an expiration. So if it expires, the whole orchestration stops. And then after the approval, once it's approved, then these are the subset of things that can happen. For example, we start creating all the relevant AD groups in Azure Active Directory for the product team. We deploy or provision subscriptions, resource groups, etc. With the template against Azure API. And we create teams, product teams, assign them to groups, assign those groups role-based access control over the Azure resources. So all of this can take time. So it's just moving forward. And then towards the end, maybe we need to update the entities. So let's examine a few of the architectural points here. We put a queue between the web app and the durable orchestrator to make sure that we do load balancing or load leveling. And actually, each activity that you see here, we implement as commands, command handler, if you're familiar a little bit with the CQRS. And so after this command has completed, we trigger an internal message. So we're also, when the command succeeds, it also publishes an internal event captured, by an internal handler. So this is using the mediator pattern. So the internal handler will notify the next command if it's time to be executed. So that's what it's doing. So the notifier will then trigger the next chain of commands and so on and so forth. So if you have commands that needs to run in parallel, then of course it's a notification. Then all the commands that implements or that will handle the same event will simply run. If an error occurs somewhere in the process, we also have a handler for errors, and we try to determine where in the process the error happened and what kind of error, because then we can decide whether we want to retry or we want to roll back or we want to move forward. It depends really on the scenario. So if it's a fatal error, we end the orchestration. But if you notice also, we have queues in some of these activities because we actually also expose them as APIs so that we're able to call these APIs directly in order to recover from the process. But if things are successful, the durable orchestration fires the last internal event, which say, hey, I'm good, I'm completed. And then the handler for that event then posts something on the event grid. So other subsystems in the different bounded contexts in different domain can react. But this process doesn't really care what happens here from this point on. So that is one of the implementation that we did. We're still learning a lot. We're still trying to optimize this. So if you have ideas, ping me, let me know if you think this is totally nonsense. Some of the design pitfalls that we really need to remember implementing this is, of course, we always have to remember all the architectural pillars also with our own queues. The performance of our queues, the reliability, how, you need to do also or think about the geo replications and redundancies of your queues because you don't want to lose your messages. So understand the concept of all your availability zones when you're deploying the storage or service bus. Of course, the cost, operationability, and security. So who can really subscribe to messages or send messages, and make sure that you understand the security requirements for that. You have to avoid building queues of queues, which means I get spaghetti list of queues. So want to try to limit the system boundaries where humans can still track them. Otherwise, if it's a really large system, I've seen in one very large enterprise we worked with that they really have a centralized department that takes care of the catalogs of all their APIs and all their event sources and who subscribe to what. But you need the tooling for that. And of course, some sort of governance way of thinking. Another thing that's very important is distributed tracing. You can use App Insight. There are a couple of tutorials that will tell you how to see all these message flows end to end. But the whole concept basically is, understanding from the very beginning that you can use correlation, or you have to correlate every single step in your distributed application to make sure that you can trace them and look at application insight, for example, by an event ID or operation ID or execution ID, and see the whole flow of events. So I've mentioned security. And other things I want to share, I put the link here. I don't have time to explain that. Is, in my dev team's toolbox so that we understand really the end-to-end of implementing event-driven architecture. We start from the design process, which is event modeling. This is our diagramming to how to illustrate and model our events. And also within our internal code, how we create our classes, our commands, our handlers with the thinking that this is event-driven. So lastly, just want to do a recap. Now you know the differences between messages and events, when to use queues, service bus, event grids, and hubs. I suggest you really learn how to model your events and try to have a large, coverage for tests to handle all the known and especially the unknown issues that can frequently happen in distributed applications. Design your tracing strategy up front, and event-driven architecture really begins with your team's mindset. So that ends my talk for the day. Thank you for your time. You can reach me on Twitter, and you can also get everything here on my GitHub account.
Awesome.
Thank you.
Thank you very much, Marilak, for this very clear explanation of making sure that even I understand the differences between the queues and the Service Bus, because that sometimes is very confusing for me from an operational background. So I really loved how you explained it, and even got me convinced to make sure that I'm switching or promoting Service Bus usage even better. Um, and basically, the only question that I had was that I wanted to make sure that I knew how to reach your code. So thank you for already answering that by reverting us to your GitHub repositories. So I'll definitely check those out. Um, and if you still want to promote ulab.org, please do so in the chat. Check if there are any more questions. But I think with your awesome recap, that well, all I can say is that I'm in awe of your presentation, and I would love to see more and talk more with you. But yeah, we also have another presenter in the
Yeah, I'm
queue
actually really
already.
looking forward to that. I'm a big fan of John Papa. I learned a lot from him in our early days building front end. So great community effort here. Thank you for your time as well. Thank you for having me.
Thank you for joining.